This is question 9 from the SACE Stage 2 Physics course companion from the section 1.2 Forces and Momentum. Here we have a multi-image diagram. We have puck A and puck B colliding. Puck B is initially stationary. The mass of puck A is double that of puck B. Now when we're drawing vectors here using a multi-image diagram, if something like this, like a puck, has double the mass, then we need to go over double the number of spaces between these images. So if this has a mass of 2m, then we're going to draw our vectors so it goes across 3 images. Since puck B only has mass m, we need to only go across 2 images. That's probably the most difficult part of answering these questions. The rest is fairly straightforward. So first we're drawing vectors showing the initial and final momentum of the system for puck A and for puck B a bit later. So here we can just put this here. So puck A has double the mass, so we're going over 3 images. Now that's the initial momentum. We'll just put that over here, PA, and that's the initial momentum of the system since puck B is initially stationary. What we need to do now is draw vectors for the final momentum of puck A and the final momentum of puck B. So that's easy enough. Let's put that here. So again, since puck A is double the mass, we need to go over 3 images. So this will be the final momentum of puck A. And we need to find the final momentum of puck B. So similarly, we'll just put this in the center of puck B. Since it's only m, we only need to go over 2 images. Looks a little bit like that, and we'll label that as well, puck B. So now we've done part A. We've drawn vectors showing the momentum of puck A and puck B before and after the collision. After this, we need to work out if momentum is conserved. So if momentum is conserved, then this plus this, which are the 2 final momenta of each puck, should equal the initial momentum of the system, which was just this puck over here. Might be easiest just to draw this a little bit to the side. So if we put that, say, here, this is puck A after the collision, and we can draw puck B. Of course, when you do it, you'll draw it by hand and make sure you use the appropriate notation for vectors. So puck B is over here. Now, if we add these 2 momentum vectors together, we get, look at that, this vector here, so momentum of A plus momentum of B, and that is the final momentum. And we can see very easily that our momentum vector of the system afterwards, PA plus PB, is in fact the same as the initial momentum PI over here. Now if this is showing that the conservation momentum is holding in this situation, the law of the conservation of momentum is that in a closed system the net change in momentum is 0, therefore the initial momentum must be equal to the final momentum, and that's what we've shown here. And there you have it, multi-image diagrams and the conservation of momentum.